Hi folks, this time we are going to talk about hydrocarbons. Now, hydrocarbons are chemicals that are made of just carbon and hydrogen. Why do we care? Well, we care because these make up a vast majority of our fuels. Everything from propane to gasoline are hydrocarbons. In chemistry, these are often referred to as the alkanes or the alkane series. And the names of these are pretty fun and easy to name. The prefix tells you the number of carbon atoms, and the suffix tells you the type of bond between them. So meth means one carbon atom, eth is 2, prop 3, bute like a butane lighter 4, pent is 5, sext is 6, hept 7, oct 8, non 9, des like December is 10, and poly means many. The suffix tells you the bond between the carbon atoms. Ein is a single bond between carbons. Ein is a double, a little bit stronger bond. And ein is a triple bond, very strong bond between those carbons. So if you know the name of a hydrocarbon, you know an awful lot about its structure, whether you want to or not. It's kind of fun. Now, methane tells me that there is one carbon atom, and they're in single bonds, but that's only one carbon atom. So carbons have a tendency to always make 4 bonds. And so this carbon is going to be 1, 2, 3, 4. It's going to be fully saturated with hydrogens. And so the structure of methane is CH4, 1 carbon and 4 hydrogens. Methane is natural gas. This is the stuff that you will probably having come into your home if you have natural gas cooking. Octane, a major component of gasoline. Oct means 8. Ane means all single bonds. And so you've got 1, 2, 3, 4, 5, 6, 7, 8 carbons in a row, and it is fully, completely saturated and surrounded by hydrogens. So C8, H18, and don't worry about that. I'm not going to have you do that right now. Let's take a look at a couple others. Propane. If you've got a gas grill, you probably have one of these, or you've probably played with a gas grill somewhere in your life. Prop means 3. 1, 2, 3. Ane means single bond, and it's fully saturated with hydrogen. If you ever hear somebody talk about saturated fats, what is it saturated with? Hydrogen. Just kind of a little bit of trivia that's kind of fun. So propane is C3H8. Ethene. Ethene is commonly known as acetylene. Acetylene and oxygen welding. Eth means 2 carbons. And ene means there's a double bond between those carbons, and then you fully fill it with hydrogens. Now, I'm not going to have you do an awful lot of these, but it's kind of a superpower, I think, when you know you can look at the name and tell an awful lot about the chemistry, which makes me feel really smart. We're going to spend a lot of time talking about petroleum. Now, petroleum is a whole mixture of all of these fossilized hydrocarbons. Now, where did they come from? Well, they came from the fossilized remains of lots of living things. The law of conservation of energy says energy cannot be created or destroyed. So where did the energy come from these hydrocarbons that we are now using that energy as fuel? Well, this is actually stored solar energy, millions of years of stored solar energy. And it works like this. For millions of years, the sun has been shining on beautiful planet Earth. Via the process of photosynthesis in plants, sunlight mixed with water and with carbon dioxide via photosynthesis have been making hydrocarbons, and then plants exhale oxygen. And that oxygen is the oxygen that you and I breathe. Now, this has occurred for millions of years, and this is where that petroleum's energy has come from. Now, the petroleum that's underground, when I was a little kid, I remember hearing people say, well, petroleum is nothing but a bunch of dead dinosaurs that were just squished and we're digging them up now. And I remember as a kid thinking, that's a lot of dead dinosaurs. And they're not really all dinosaurs, probably some of them are, but it's mostly tiny marine plants and animals. So we're talking plankton and krill and tiny things that lived in the ocean millions of years ago, died, sunk to the bottom, got covered with sand and silt, and with a lot of heat and pressure and time, liquefied. And as these liquefied, they went from their complicated long molecules, they went from their big complicated forms of life to this big mix of hydrocarbons, these odd collections of carbon and hydrogen molecules that we refer to as petroleum. So where do we find petroleum today? Well, we find it in places that used to be under the sea. So in the United States, there used to be a vast inland sea that stretched right through the middle of the country. And that's where a lot of our oil fields are, out into the Gulf of Mexico, up through Louisiana, Texas, Oklahoma, and up into the Dakotas. California, if you go in Southern California, there's oil fields and shopping malls, parking lots. They're all over the place. There are some up in the northeastern part of the United States. Coal areas used to be also primordial bogs and forest areas, but usually freshwater, so that there was a different kind of decay mechanism that happened to those forests. And that's why you have these big coal fields under West Virginia and these parts of the United States. So these are also decayed leftover energy from the sun that we are harvesting and using. When the petroleum industry sucks this out of the ground as fuel oil, they have to separate it out because you use methane one place and diesel fuel in another. So how do they do it? They separate it in something that is referred to as a fractional distillation process. And it goes through a furnace. The furnace heats the crude oil. And then it goes into one of these fractional distillation towers. The lighter gases rise up, the heavier solutions fall down. And then there are side vents that take off each fraction, and the fractions are pulled out depending upon the temperature at which it turns into a gas. So up at the top, near the top of the fractional distillation, you are going to get the lightest molecules, things like methane that are in your stove, propane that you're going to use for your grill, butane that's going to be in your lighter. Now, these are both gases at room temperature, but under pressure, they're liquids. Octane that you put in your car, octane is actually a blend. A gasoline is really not just octane. It is a mixture of 5 carbons long to up to 12 carbons long. And it's that blend of different carbons of different lengths that we refer to as the octane rating. You get longer molecules, and as the molecules get longer, they get heavier. And you end up with kerosene or Jet A. Jet A fuel, bigger molecules are going to have more power, more punch per molecule. Bigger molecules, you're going to end up with diesel. Bigger still, they're going to be goopier, thicker, and you're going to end up with motor oil. Further down still, you're going to end up with fuel oil that are used by ships. If you're going on a big tanker across the ocean, you are going to need something that is going to have a lot of power in a small amount of space. You're not going to burn methane. You're going to burn something that's got a lot of oomph to it. And that's going to be something like fuel oil. And then the longest chains that are going to stay goopy, almost as solid, that are going to go poof, fall to the bottom of the distillation tower, that's going to be your road tar. Mix that with some gravel, and you can put it and smear it all over the road. Now, the energy from this combustion comes from a simple burning. So we take these hydrocarbons, carbon and hydrogen, some mixture of them, some number of carbons and hydrogens. When you burn anything, that means react with oxygen. And so these are burned in oxygen. When things burn, the products are carbon dioxide, water vapor, and energy. What's cool is this is exactly the same chemical reaction that happens when you and I eat. When you eat your cheeseburger, you eat a carbon-hydrogen mixture, you burn in oxygen, you breathe in oxygen, that's where you get that. You breathe out carbon dioxide, you piddle out water, and you release heat energy. This is why you have to sweat and perspire. You've got to get rid of that energy. It also makes you warm and cuddly. When your car burns octane or gasoline blends, this combustion reaction, carbon dioxide, one of the things coming out of the tailpipe, but you also may notice sometimes a little water vapor that might condense, and that is part of the combustion products. Now let's talk about air pollution. Living things contain carbon, hydrogen, oxygen, nitrogen, and sulfur. These are the most common elements in all living things. When petroleum is mined and people pull that out of the ground, they're most interested in that carbon and hydrogen. But they're also going to get the nitrogen and sulfur. Where does that come from? A lot of it is coming from the proteins that made up the muscles of those little creatures that decomposed. The nitrogen and sulfur are impurities. They're impurities that just are there. And if these are in with the petroleum and they're part of the combustion and they burn, they make things that are referred to as NOxes or SOxes, nitrogen oxide compounds or sulfur oxide compounds. Now, nitrogen oxide compounds tend to produce brown, smoggy air. If you go to a big city and there's like a brown haze around everything, those are nitrogen oxide gases. Not very pretty and really bad air pollution. Sulfur oxides smell like rotten eggs. And these sulfur oxides, and when they mix with water, it takes a couple chemical reactions for that to occur, they can make acid rain, which is very hard on plants and animals and very hard on buildings and structures. Acid rain is a bad, bad thing. So what we've done is they've come up with some ways to make this better, aside from being more thoughtful about which petroleum we use, which coal we burn. One is to put scrubbers on smokestacks. What a scrubber can do is help remove some of those sulfur oxide compounds by reacting them inside the smokestack to make a sludge of sulfur compounds fall out so that they never get out in the air. That's one way that, especially in a coal burning plant, they can get that sulfur out of the air and help eliminate an awful lot of that acid rain. In a catalytic converter in an automobile, that eliminates an awful lot of those nitrous oxide compounds, because a catalytic converter and that lovely palladium, that very expensive palladium catalytic converter, what's it going to do is that gives the gases as it goes through here time to fully combust, time to fully react, so that what comes out of that tailpipe is going to be water, carbon dioxide, and nitrogen gas instead of carbon monoxide, which is an incomplete combustion gas, and that nitrogen oxide, which will give you that brown smog. So this was a quick overview of petroleum and petroleum products, and we'll come back later and we'll talk some more about these energy of combustion. See you later. Bye.